So today we are going to see pointers in C in detail. So we already discussed the introductory part. So today we are going to discuss much more things about pointers. First one is double pointer. So here we all know what is a pointer. Pointer is a variable which can hold address of another variable. So you just look at the diagram. Here I have variable avg. Its address is 4096 and that 4096 is stored in ptr. So ptr contains 4096 and now ptr points to avg. ptr points to avg. Since ptr is a variable, it also can have an address. Let the address be 5000. That address I am storing it in another variable called pptr. So this is called double pointer. pptr is a pointer to another pointer which points to the actual variable. So I'll explain with the help of an example. Main int star ptr comma k equal to 5 ptr equal to ampersand of k. So here it is k equal to 5. So in ptr we stored address of k. So I am declaring another pointer which is pointer to a pointer. So that is declaring by 2 stars. So here pptr equal to ampersand of ptr So 1 minute. So here I have some variables ptr Then I have variable pptr and another variable k. So ptr, before that there is a star, so it is a pointer variable. The type is integer. Similarly, pptr has a double star, so the meaning is it's a double pointer, and in the end result it is also pointing to an integer. So ptr will have some value. What is that value? Ampersand of k, address of k. So let the address of k is 500. So 500 is in ptr. pptr equal to ampersand of ptr. Let the address of ptr is some 600. So that 600 is stored in pptr. 600 is there in pptr. K is already 5. So here I am trying to print ptr. Value at ptr is 500. So 500 will be printed. Here I am trying to print star pptr. Star means value at or dereference operator. pptr contains 600 and we are going to print value at 600. Value at 600 means 500. So the meaning is for these two statements the value, the output will be same. The output will be same. So if you notice the output will be same because it is referring to the same address. Here listen, star pptr. First you have to look at star pptr. Star pptr means value at pptr. Value at 600. That is 500. Again you have to look at this one. Star pptr is already 500. So star 500 means value at 500. Value at 500 is 5. So the expected output will be 5. So here I got the value as 5. So I think these statements are enough to understand double pointer. So is it clear? Is the concept of double pointer clear? If it is clear, please respond with a clear message. So just remember these two statements. First is to store address of that variable in ptr. Next is to store address of ptr to pptr. Okay. Anyway, it's also generally it actually have some application while we studying two-dimensional array and pointers. So anyway, if you can understand the pointer concept, double pointer is also very easy. So I'm moving to the next topic. Array of pointers. So before that, I will try to write an example. We all know what is int a of 10. Int a of 10 means a can hold 10 integer values. A can hold 10 integer values. Similarly, what will be int star a of 10? We all know what is int star a. Int star a means a is a pointer variable which can hold address of another variable. Similarly, int star a of 10 means that a is a array which can hold 10 address values. Each of the 10 address value will be pointing to integer. Same concept. You just compare with the normal array and the pointer array. And also you have to compare with the normal variable and the pointer variable. So here anyway it's an array. Its name is A. Since it is a star, A is an array of pointers. That means each cell can hold some address. Each cell in the array can hold some address, and the address must be pointing to some integer variables. So array of pointers is nothing but an array which can store a set of pointers or set of address. Example, int star p of 10. This declares an array of 10 pointers, each of which point to an integer. The first pointer is called p of 0, the second is p of 1, and so up to p of 9. So here what happens, I have an pointer array. I have declared 3 integers. P of 0 equal to ampersand of a. So in the first cell I have stored address of a. P of 1 equal to ampersand of b. So here in this cell I have stored address of b. In the third cell I have stored address of c. So the first cell is actually pointing to a, integer variable a. Second cell is actually pointing to integer variable b. Third cell is pointing to integer variable c. Okay, suppose 1 minute, I will write a program. ptr array.c main. So you have to understand, study the declaration. Int star ptr of some 5. Okay. Then int a equal to 5, b equal to 10, comma c equal to 15. ptr of 0 equal to ampersand a, ptr of 1 equal to ampersand b, ptr of 2 equal to ampersand c. Fida Sahuda, can you hear me?
Yes, yes, sir.
What will be the output of this program?
say ampersand A, ampersand B, ampersand C.
Ampersand A means?
Address of A. Sorry, sir. Value 5, 10, 15.
Okay, 5, 10, 15 will be the output. Very good. Okay. So we'll explain the program. Here is some error. I undeclared. So I'm just declaring along with the integer, comma I. 5, 10, 15. So here I have an array with 5 cells, size 5. 1, 2, 3, 0, 1, 2, 3, 4. So index value ranging from 0 to 4. Its name is PTR. What will be the content? Content will be pointer. So content will be an address. Points to some integer value. Some integers also A, B, C. PTR of A, B, C, some integers. So PTR of 0 equal to ampersand A. So here I am going to store address of A. Let it be 100. So here 100 will be there. Then PTR of 1 equal to ampersand of B. Let address of B will be 200. So here 200 will come. Similarly here address of C is 300. So here I am storing 300. So for I equal to 0, I less than 3, I plus plus. So the valid I values are 0, 1 and 2. 0, 1 and 2. First it will print star PTR of I. What is PTR of I? PTR of 0. PTR of 0 is 100. What is star 0? Value at 100. A contains 5. So value at 100 means 5 will be printed. Then for 1, star PTR of 1. PTR of 1 is 200. Star PTR means value at 200. So in B I have 10. So 10 will be printed. In C we have 15. So 15 will be printed. 15 will be printed. So this is only to understand the concept of array of pointers. So it is applicable when we study the next topic. So understand the concept clearly. So array of pointers means it is an array which contains some address. That's it. Is it clear? Is the array of pointers clear? If it is clear, please respond with a clear message. If anybody have any doubt, you can ask. Okay. Next is pointer arithmetic. So similar to normal arithmetic, we can perform some arithmetic operations on pointers. First point, we can't perform every type of arithmetic operation with pointers. That means we can perform some sort of arithmetic operations. The valid arithmetic operations applicable on pointers are addition of integer to a pointer. So we can add an integer to the pointer. Subtraction of integers from a pointer. So a constant value or an integer value can be subtracted from the pointer. Subtraction of one pointer from another of the same type. If we have two pointers of the same type, we can perform subtraction. Increment and decrement of pointer. After increment means plus 1, decrement means minus 1. After increment or decrement, it is not necessary that the pointer variable still points to valid memory location. So this point I will explain with the help of an example. Pointer arithmetic is based on scaling factors, that is size of data type. So this one also it will be clear when we discuss the example. Such scaling factors necessary for pointer arithmetic are taken care of automatically by the compiler. Again, this will also clear when we discuss the example. Generally, we use pointer arithmetic with arrays because elements of an array are arranged in contiguous memory location. So we already studied array is a group of elements of same data type, and these elements will be in contiguous memory. That means in the continuous memory location. So suppose I have an character array, we already discussed it, of 10. I have a RAM. So not 10, let it be some 3. So I have a RAM. So character array have 3 elements. So since it's a character, we need 3 bytes. So 3 bytes will be allocated to store this array. And these memory locations will be a nearby memory location or adjacent memory location or continuous memory location. Let the address be 100. The next character will be in 101. Next character will be in 102. So if it is an integer, the first integer will be in 100. Next integer will be not in 101. It will be in 104 because 4 bytes will be taken by integer. So we already studied one function called size of function. In the last class we studied size of function, which will return size of a particular data type. Those things also you have to consider here. Okay. So we use pointer arithmetic with arrays. This one we discussed today itself. Relational operators are used to compare 2 pointers. So all type of relational operators can be used. That means we can compare 2 pointers with the help of less than symbol, greater than symbol, less than or equal to, greater than or equal to, equal to, and not equal to. All type of relation operators are applicable to pointers. Do not attempt following arithmetic operation on pointers, they will not work. Addition of 2 pointers is invalid. Multiplying a pointer with a number is invalid. Dividing a pointer with a number is also invalid. So only valid operations are addition of integer to a pointer, subtraction of integer from a pointer, subtracting one pointer from another of same type, increment and decrement operator. So I will explain with the help of an example. PTR arithmetic is what we are studying. Int star PTR. So I have an integer pointer variable declaring another integer variable along with that k equal to 5, PTR equal to ampersand k. So first one is I am going to perform addition of integer to a pointer. So I am writing printf %d comma PTR. First I am printing PTR. So it will print address of k. So it produces some address 6684180. Suppose instead of PTR, I am going to print PTR plus 1. So listen carefully. I am going to print PTR plus 1. Normally, what will be the output? PTR is this one. Plus 1 means 6, 6, 8, 4, 1, 8, 0. 8, 0 plus 1 means 8, 1. So this will be the normal output, normal addition. But it will not be the output. It is 6684 184. Some 4 is added. Some 4 is added. So Y4 is added because PTR is an integer pointer. So what is size of an integer? In this computer, the size of integer is 4. Last class we studied size of. In this computer or in most of the computer, size of int is 4. So that is actually added with this pointer. So what happened is PTR plus 1 star 4. 1 star 4. So 1 means this one. So what's the meaning? Okay, listen carefully. So I have a PTR. I have K 500 5. Address of K, let it be 500. PTR I will store 500. So PTR is an integer pointer. So K is also an integer. So it will take 4 bytes. So the memory locations 500, 501, 502, 504. These 4 bytes will be allocated to K. These 4 bytes will be allocated to K. And the address of this entire block will be considered as 500. So when I am performing 501, it will be pointing to 505 actually. Sorry, here it is 3. Here it is 3. 1 minute. Here it is not 4. Here it is 3. 500, 501, 502, 503 will be used to store 5 or is allocated for K. So when I am performing K plus 1, it is actually pointing to the next valid address location. 501, 502, 503, everything goes along with K. So plus 1 means plus 4 because K is an integer data type. K is an integer data type. So here I got 6684 194. Suppose I am adding 2. Saget Kumar.
Yes, sir.
So plus 2 means how many will be added along with PTR? Okay, during plus 1, how many is added along with the PTR?
4, sir.
4. So plus 2 means what will happen? Plus 2 means plus 1 plus 1. Plus 1, 4 is added. Again there is a plus 1. So what will be added? 1 more plus 4 is added.
8, sir.
So 8 will be added. That's why I have written here 1 star 4. Similarly, plus 2 means it will be 2 star 4. So the expected output will be 6684188. So you can mute the mic. So 6684188. So I will print all these three values. PTR I am printing, PTR plus 1 I am printing, PTR plus 2 I am printing. Okay, one slash n also I will give, or some space will be given. So here 6684180, then plus 1 means 4 is added. Why 4 is added? Because PTR is an integer pointer and size of integer is 4. That's why 4 is added. Similarly, again some 4 is added because size of integer is 4. So I am changing PTR to char and I am storing character 5 in K. I am executing the program. Now it is 6684183. 8485. Why? It is actually similar to integer addition. Why? Because character needs only 1 byte. Character needs only 1 byte. So here I changed it to character. That means PTR is a character pointer. K is also character, which contains character 5. So instead of character I am using double. Double, the size is actually 8. So 8 will be added. There will be a difference of 8 with nearby numbers. 76 plus 8 is 84. 84 plus 8 is 92. Okay. Similarly, in a subtraction is also a valid operation. Subtraction is also valid operation. Subtraction of integers from a pointer. Subtraction of integer from a pointer. So it is also a valid operation. So let it be minus 1, minus 2. So here again I am declaring PTR as integer. K is also an integer. So there will be a difference of 4. First one is 80. Minus 4 means 76. 76 minus 4 is 72. Increment and decrement operator. Increment and subtracting one pointer from another of the same type. Subtracting one pointer from another of the same type. Okay. So I am declaring one more pointer, comma, star PTR1, comma, x equal to some 10. X equal to some 10. PTR 1 equal to ampersand x. So I have 2 pointers, PTR1 and PTR and PTR1. So here I am performing PTR minus. Okay, first I am printing those two values, PTR and PTR1. Then I am performing PTR minus PTR1. Here star PTR is an integer pointer, K is integer, PTR1 is integer pointer, X is integer. Address of K is stored in PTR, address of X is stored in PTR1. I have printed PTR, I will print PTR and PTR1, then the subtraction. So here I missed a semicolon. Here 6684172, 6684162. So the normal Normally what happens, the 72 minus 68 will be 4. So why it is 1? Because earlier when I added something, I have multiplied that size. So here I will divide that size. Size of integer will be divided. Size of integer will be divided. So it is actually 4. 4 by 4 equal to 1. After taking the difference, I had to just divide by size of the integer pointer. So the next is increment and decrement. So here I have PTR, then I have PTR plus plus. So let me check the output. Here the both produce same output. Why? Listen carefully. You already studied PTR plus plus is a post decrement, post increment. So first PTR will be printed. So that PTR is printed. Then it will be incrementing. Actually the value of PTR is changing, but before changing the value it is printed because it is a post increment value. So I am just changing to plus plus PTR. So now I am getting 72 and 76. Here also generally plus plus means incrementing by 1. Here it is not incrementing by 1. Here it is incrementing by size of the data type. So I hope all these 4 pointers are clear. Pointer arithmetic is based on scaling factors. So I hope you understood what is scaling factor. Scaling factor means size of data type. Such scaling factors necessary for pointer arithmetic are taken care of automatically by the compiler. Actually, we are not specifying anything to add 4. So it is instead of 1, the 4 is automatically added by the compiler. When it is integer, it is 4 is automatically added by the compiler. When it is double, 8 is automatically added by the compiler. Generally, we use pointer arithmetic with arrays because elements of an array are arranged in contiguous memory locations. So that one we study later. So I hope you understood pointer arithmetic. So if you are adding a constant with the pointer, that size of into constant will be added. Similarly, subtraction also. Pointer minus that constant into size of data type. So these operation can't be performed. Addition of 2 pointers, multiplying a pointer with a number, dividing a pointer with a number. Sometimes if you execute some programs, it will give you some values, but it is of no application. What we have discussed have some application that we will study next. Any doubt in pointer arithmetic? Please respond. If it is clear, please type a clear message. I am only getting few responses. Okay. One-dimensional array and pointers. Elements of array are stored in successive increasing location of memory. I already told you, when we declare an array, some space will be allocated and that will be in contiguous memory location or in continuous memory location. And actually it is in successive increasing location of memory. Array notation is a form of pointer notation. This point will be clear after studying these things. The name of the array is the beginning address of the array, called base address of array. Base address of an array is the address of 0th element of the array. So here I have an integer array. So suppose I am trying to print, I am writing some value, printf. Some percentage d, comma a. So this one, if you can understand this one, it will be very easy. So I am trying to print a. So okay, before that there is an array which contains 5 elements, 10, 20, 30, 40, 50. So a of 0 will contain 10, a of 1 will contain 20, a of 2 will contain 30, a of 3 will contain 40, and a of 4 will contain 50. And some memory is allocated each cell. First, the address of first cell is some 270. So since it is in continuous memory location, that means the next continuous memory location, the next cell will be in address location 74. Address location 74. Why? Because integer is taking 4 bytes. So 70, 71, 72, and 73. These 4 bytes will be allocated for a of 0. These 4 bytes will be allocated for a of 0. Am I audible? Please respond. Am I audible?
Yes, sir.
Okay. So these 4 bytes are allocated for a of 0. So the next memory location 74, 74, 75, 74, 75, 76, and 77 will contain 20. Similarly, so again 74 plus 4 is 78. 74 plus 78 plus 4 is 82. 82 plus 4 is 86. So when we declare an array, it will be allocated in continuous memory location or successive increasing location. So the memory location will be like this. If it is integer, it will be added by 4. If it is a character, it will be added by 1. If it is a double, it will be added by 8. Okay. Okay, one more thing. Suppose I am printing the value of a. Value of a will be same as the address of first cell. The value of a will be same as address of first cell. So that's why I have written here a equal to ampersand a of 0. What is a of 0? First cell. What is ampersand a of 0? Address of first cell. So here this equal to is not an assignment operator, to just denote address of first cell is same as name of the array. Here actually a is name of the array. If I am trying to print the name of the array, I will get an address value. That address will be same as ampersand a of 0 or address of first cell. So what will be star a? So now the meaning is a contains this address, some 21 followed by some 70. So what is star a? Star a means value at a. Value at a means value at this address location. Value at that address location is 10. So what is a of 0? A of 0 means 10. What is star a? Value at this address location, that is also 10. So star a and a of 0 are same. Okay. So here a is 21 followed by some 70. What will be a plus 1? What is a plus 1? This a is a pointer now because a contains some address. A plus 1 means a plus 4. The previous slide we studied about pointer arithmetic. A contains some address. So a plus 1 means it is not 71, it will be 74. What is 74? 74 is pointing to 20. 74 contains 20. So a plus 1 means this address value. That cell is denoted by a of 1. What is ampersand A of 1, ampersand A of 1 is this value, this address value. So that's why here I have written A plus I is same as ampersand A of I. A plus I is same as ampersand A of I. So it will be clear when we discuss the examples. Similarly, now A plus 1 is actually 74. Some value 74. So what is star A plus 1? Star A plus 1 means star some value followed by 74. So that means the value at that address is 20. So star A plus 1 is 20. What is A of 1? That is already we studied. If I am trying to print A of 1, what will I get? I will get 20. So star A plus 1. That means A plus I is same as A of I. A of I. Now I have came to a conclusion. Star of A plus I can be written as star of I plus A also. That is A of I. That is equal to I of A. Okay, these points will be clear when we discuss the example. The expression A of I means the address of ith element beyond the one A points to. Beyond the one A points to. So when we create an array, internally there will be one pointer is also assigned. There is one pointer assigned whose name will be same as array name, and its content will be same as the first cell's address. The content will be same as address of first cell. So here it will be some 70. Okay. So anyway, I will try to explain with the help of an example. One more thing, A plus I. This is not measured in number of bytes, but in number of size of type bytes. So we already discussed plus 1 means plus 4 for integer. Plus 1 means plus 8 for a double. Plus 1 means plus 1 for a character. That is called scaling. So I will try to explain with the help of an example. Pointer and array dot c. Okay. The basic thing you have to understand is this. Suppose I have an integer array. Int a of 5. If we can understand this basic concept, it will be very clear. Int a means I have an array of size 5. So index value will be 0, 1, 2, 3, 4. So this is the array. So when I declare an array, so one pointer variable also will be created. Those things are internal working. And the name of that pointer is A. Name of the array is A. One pointer will be created. That pointer also have the same name. And 4 cells are allocated. So 5 cells are allocated, each are of integer. So let it first address value will be 100. Next address value will be 104. Next will be 108. Next will be 112. Next will be 116. So what will be the value of A? A contains 100. A contains 100. So actually A is pointing to first cell. A is pointing to first cell. First I will print the value of A. Printf for easy understanding. I am printing values. comma A. Now I got an address value 668,668,4160. Along with that, I am printing another address value, percentage D, comma, ampersand A of 0. Both are same. What's the meaning? Ampersand A of 0 means address of first cell. A means this pointer. Both contain same value. So it is pointing to the first cell. Printf. So I am storing some values also, equal to 10, 20, 30, 40, 50. I'm storing some values also. Control C, Control V. Here I am just giving A plus 1. Here I am giving ampersand A of 1. What is A plus 1? A is an integer array. So A contains 100. So 100 plus 1 means 100 plus 4. That is 4 bytes. So what is ampersand A of 1? Address of first cell. That is also 104. So I am executing the program. One more line I will add, /n. So here, first address value A and ampersand A of 0 are same. Now I have added 1. So A plus 1, that is 64. That is same as ampersand A of 1. So what it is clear, A plus 1 and ampersand A of 1 are same. Similarly, A plus I is same as ampersand A of I. A plus I is same as ampersand A of I. From this one it is clear. A plus I is same as ampersand A of I.
Sir,
So please ask.
sir, we have class at 9 EVS.
9 or 9:30?
Sir, 9.
So ma'am told me it is at 9:30, na? You got it information as 9.
Yes, sir.
So I think it is at 9:30. So I will
9:30.
okay. Only I will take only up to 9:15. Okay. Okay, here you just listen. So A plus I is same as ampersand A of I. Okay. So I am writing one more printf statement. Control C, Control V. Star of A plus 1. Here what is A? 100. A plus 1 is 104. What is star of A plus 1? Value at 104. Value at 104. What is value at 104? It is 10, 20, 30, 40 and 50. So value at 104 is 20. Value at 104 is 20. Similarly, I am going to print one more thing. A of 1. A of 1 we already know. A of 1 refers value at index position 1. That is also 20. So let me check the output. Here 20, 20. So star A plus 1 and A of 1 are same. So one more interpretation I got. This is the conclusion I want to convey. Star A plus I is same as A of I. A of I. So in the end of the session, you have to understand these things. A plus I is same as ampersand A of I. Star A of A plus I is same as A of I. One more thing. This is only for understanding purpose. This statement, what I am going to write, 1 plus A. 1 plus A is same as A plus 1. So I am just writing an interesting thing. Instead of A, I am writing 1. Here it is. I am writing A. So this one you may feel something very strange, but this one also work. 2020. Okay. So this is a very interesting thing. You may feel it's something strange, but it also works. Okay. Now I will write a for loop. For I equal to 0, I less than 5, I plus plus, comma I. Sorry, here what I intended is I. So let's look. After dot, I got 10, 10, 20, 20, 30, 30, 40, 40, 50, 50. Now it is clear. Star A plus I is same as A of I. Similarly, I will print one more thing. Here I am removing the stars. A plus I. A plus I already told you it is same as ampersand A of I. Now look at that. These addresses are also same. So these are the points you have to understand from this. A is same as ampersand A of 0. Star A means A of 0. A plus I means ampersand A of I. Star A plus I is A of I. A plus I, star A plus I means star I plus A, that is A of I, that is equal to I of A. These things are the outcome. These things are the outcome. So when we read and print array, we used, okay, I will take that program. Okay, we already discussed some read array and print array.c. So instead of this ampersand mark of I can write mark plus I, because we already studied ampersand mark of I is same as mark plus I. Similarly, what is mark? Mark of I can be written as A of I can be written as star A plus I. So here I can write it as star mark plus I. So this program also will work. Send a number of students, 3. One minute. Okay, enter number of students. Here I didn't print the value statement, so I am entering 3 values, 20, 30, 40. So the entered marks are 20, 30, 40. So I hope you understood the concept. So now I am coming back to array. Here we studied array notation is a form of pointer notation. Array notation is a form of pointer notation. This A of 0 is an array notation. This ampersand A of I is an array notation. But star A is a pointer notation. A plus I is also pointer notation. Similarly, A of I is an array notation. Star A plus I is a pointer notation. So array notation is a form of pointer notation. Any doubt, please ask. So you have to understand this conclusion. That's the only thing. Is it clear? If it is clear, please respond with a clear message.
Sir, can you again explain that student problem?
Which one? Mark.
Student one.
Student mark. Okay. So for confusion, I am adding on printf statement here. Printf. Enter. Marks of percentage D students. Comma in. So for, and also changing the size also, I'm just giving 5. Okay. So you have to answer. I will ask some questions. So here I have a mark array. Size is 5, 0, 1, 2, 3, 4. So I already told you, when you declare an array, one more internal pointer is also created. So there is a pointer whose name is actually mark. So let the address of first cell is 200. Next it will be 204. Next it will be 208. Next it will be 212. Next it will be 216. Shidindraj. Adarsh Kumar.
Yes, sir.
So what will be the content of this pointer mark? Please say the answer. What will be the content of this mark?
Um,
Okay, you can mute the mic.
200.
Okay, 200. 200. Very good. So this mark is actually pointing to array. Okay. So n is, I am entering n as some 3. So this for loop will execute for 0, 1 and 2. Essentially it will be 0. Scanf percentage D mark plus I. Mark is 200. 200 plus 0 is 200. So otherwise what will I write? Scanf some ampersand A of I. That is the earlier notation. I changed it to mark plus I. What is I? I is 0. A of 0. What is ampersand A of 0? It is 200. It is 200. So actually in scanf statement, as a second argument, we are giving address. So here after comma, I am giving an address. That is 200. So what is mark plus I? 200 plus 0. It is also same. 200 plus 0. Then I becomes 1. Mark plus 1. 200 plus 1. 200 plus 1 means, since it's an integer, 200 plus 4 will happen. 204. So percentage D comma 204. Earlier it is ampersand a of I. A of I means a of 1. Address of a of 1 is 204. So in 204 the second value will be stored. Is it clear?
Yes, sir.
So any doubts? Okay.